Well, hello, science explorers. It's Carrie here with the Go STEM Explore Science Club. I hope you had a chance to watch the video about the Powder Basin Watershed Council. Christo, the director of the Watershed Council, showed us some really special places along the Powder River. He also explained that Eastern Oregon is a lot drier than Western Oregon because of something called the rain shadow effect. Now, in this Discovery Challenge we're calling Water Chemistry Curiosities, we're going to go below the surface and learn how water chemistry plays an important role in the rain shadow effect. To make some water chemistry discoveries, we're going to start with two activities. For the first activity, saltwater painting, you'll need some paper for painting on, some small paint cups, which Dixie cups could work, a paintbrush, and any kind of relatively small paintbrush works, 1 to 3 teaspoons salt, 1 to 3 teaspoons warm water, 1 to 3 colors of food coloring, and a tray or newspaper to keep messes contained. For the second activity, cold water questions, you'll need a small cup or jar. Something made out of plastic or glass would be great. You'll need a Ziploc bag big enough to put your cup or your jar into. You'll need some ice, some cold water, and also some warm water. For activity 1, you'll set your paper on the tray or newspaper, and you'll mix about 1 teaspoon of salt with 1 teaspoon of warm water, and mix with your paintbrush. And then you'll add your food coloring. You can mix as many containers of colors as you want. 2 to 3 might be nice. I'm going to use green and red, but 1 color works too. And be sure to keep your paint mixed as you go. And also keep 1 cup with just water for cleaning your paintbrush. Then paint your paper. Feel free to paint anything you like. Once you're done, set it off to the side in a warm spot. Directly in the sun is even better. We'll come back to it. For activity 2, cold water questions, you'll start off by filling your small container, I've got a little mason jar here, with ice and water. And then you'll put warm water into your Ziploc bag. Put in enough water in the bag just to create a little layer at the bottom. You'll place your cup of ice water into your bag of warm water. As you do so, observe your cup for a moment. Look at its surface. Zip it closed and let it sit for a minute or 2. Then go check your painting. What's happening there? If not much has happened, wait a little longer. Let's go back to your cup in a bag for cold water questions. Take the cup out of the bag and observe the side of the cup. What do you notice? When I put the jar in the bag, the sides were dry. Now there are drops of water on the sides of the glass. Where might that water have come from? Here's my saltwater painting. With some time, the paper dried. The water is gone, but the salt and coloring are still there. Where did the water go? Let's start at the beginning. Atoms are the basic building blocks of all matter. So everything from your skin and bones to the building you are in and the soil underneath it is matter and made of atoms. Even air and water are matter. And matter can be solid like our bodies, it can be liquid like water, or gas like air. And atoms, those building blocks of matter, come in different kinds called elements. Examples of elements are oxygen, carbon, hydrogen, iron, and calcium, and that's just a few. Last I checked, there are 98 different elements found naturally. So all the different things you see around you, all the matter on Earth is made with those 98 different elements. Wow, huh? So when two or more atoms attach to each other, they become a molecule. And a water molecule, the kind of molecule and atoms we're focusing on today, is made of 3 atoms. 2 hydrogen atoms attached to 1 oxygen atom. And when bonded together or connected, water molecules look a bit like Mickey Mouse, don't you think? So when water is solid, it's ice or snow, like the snow in this forest. And when water is liquid, well, it's liquid like in this lake or the water we drink. And when water is a gas, it's called water vapor, like the steam in this cup of tea. And to understand more about the rain shadow effect, we're going to focus on when water changes from liquid to gas and from gas to liquid. All right, you're doing great, everybody. So water molecules have a positive side and a negative side. The hydrogen side is positive, and the oxygen side is negative. Like magnets, water molecules stick together. When water molecules are relatively cool, they don't move fast, so their positive and negative ends stick together. This is when water is a liquid. And when water molecules are warm or hot, they move around quite fast, so quickly that their positive and negative ends aren't able to stick together. And this is when water is a gas or water vapor. When liquid water heats up, it changes from liquid to water vapor. That is called evaporation. So that is what happened when your painting warmed up. Your saltwater painting, that is. The water evaporated, changing the liquid water to water vapor. But the salt and the food coloring stayed on your paper. All right, how about the opposite? When water vapor cools, the molecules don't move fast, so their positive and negative ends stick together. This is when water changes from a gas to a liquid, and that is called condensation. And that is what happened in the cold water questions activity. In fact, both evaporation and condensation were going on with your cup in a bag. Water was evaporating from the warm water, changing from liquid to water vapor. And when the water vapor hit the cold cup, it condensed and became a liquid again on the surface of the cup. Wow, chemistry is really cool. Now, we observed evaporation with our saltwater paintings. And I want you to think about, when else have you noticed evaporation? You might want to think about times that you've gone swimming and what happens after you're done swimming. And then also think about condensation. When else have you noticed condensation? And this one's a little bit harder. You know, think about a cool morning, maybe a cool fall morning, and you go outside and the grass is wet, but it hasn't rained. What's going on there? Now we're going to apply the water chemistry to the rain shadow effect in Oregon. You'll need some paper and some markers, because together we're going to draw and label a rain shadow diagram. And if I tend to go too fast for you, just feel free to pause the video, catch up, and then start it again. We'll begin our drawing with the ocean. And then we'll continue with the land and the mountains. We also need the sun. And an important part of the rain shadow effect is that the main winds blow from west over the ocean to east over the land. In the ocean, the water is liquid. All the water molecules float around connected like magnets. The sun shines on the surface of the ocean and the liquid water heats up. What's that word when water changes from liquid to gas? Yes, evaporation. The heat makes the liquid water move around so much that some of the water molecules escape and evaporate into water vapor into the atmosphere, just like the water did on your saltwater painting. Winds blow the water vapor over the land, and as the wind pushes water vapor onto the land, it's also pushed up as it tries to move over the mountains. The higher you go up the mountains, the colder it gets, and maybe you've experienced that. So what's that word when water vapor cools and changes to liquid? You got it, condensation. The water molecules slow down so much that the positive and negative ends connect, and they condense into a liquid in the form of a cloud. Just like the water condensed on the sides of your cup in your experiment. If enough water condenses in those clouds, large drops of water form in the clouds and fall as rain or snow. Now, there isn't much water vapor left in the air as we move past the mountains, creating a dry zone on the east side of the mountains. That dry zone is considered a rain shadow. The mountains form a shadow where not much rain falls, and this phenomenon is what we call a rain shadow effect. And rain shadows don't just happen in Oregon. They happen in the states of Washington and California, as well as the Rocky Mountains, and other countries and continents across the world. Those 2 hydrogen atoms and 1 oxygen atom, they certainly have a large influence, don't they? Well, I hope that you've enjoyed learning about the connection between water chemistry and rain shadows, and I also hope that you keep discovering new ways that water chemistry impacts your life. Until next time, keep exploring.